Hello and welcome. My name is Gursahib Singh. I'm the current research director of ICDC. Behind the camera, we have our research associate, Ted Notch. We are standing on the agri-food station based in Outlook. For this video, we are highlighting one of our study we have on the station. It's a wireworm studies. So in the past few years, wireworms have been, we are struggling, or we are seeing some damage of wireworms on the station. So we thought we should do a study to how we can control the wireworms, especially in cereals. For this study, we are looking into different seed treatments and seeing them particularly in wheat, and seeing how those seed treatments control or they manage the wireworms. So for this study, we are looking into 4 seed treatments. We are looking at the first product is Traxa. It's a new product which is it's a new product which is recommended for control of wireworms, especially it's resistant in wheat. And then the other 3 products, those are old chemistries. Those are Cruiser, Stress Shield, and Lumivia. So we're comparing how each of those products affect the wireworm populations. So we seeded this wheat in mid-May, and for the wireworms, for wireworm populations, we are setting up traps within the plots. Normally our plot size is 2 by 10, but for this study we have a double wide plot, so it's 4 by 10, double the area what we usually do for the other studies. And we were setting up traps in the 4-inch pots. So for the 4-inch pots, we are filling the pots with a vermiculite, and then a layer of wheat, and then a vermiculite. And we are placing these pots at the edge of each plot. Our plan for this study was to set up 4 traps, right at seeding, then at stem elongation, then and then late anthesis stage, and then we will do one more at the last, close to maturity. So far we have done 3. We have set up the traps 3 times and dug the trap 3 times and counted the worms. So what we found was control. There was a lot of activity of wireworm, and we were finding a lot of worms within these traps. For the new product Traxa, which is actually the chemistry says that it would actually kill the wireworms rather than the other products which doesn't kill the worms but they repel the worms. So for the Traxa, we didn't find any worms within the trap, which is a good news. I haven't looked into much detail how the other 3 products or the whole chemistry, how they differ with the wireworm population, but so far for Traxa we are seeing some good results. And so these results, once we have the wireworm traps, the last wireworm traps toward the end of the maturity, and then we will harvest the plots, and we will also look at the yield, how the insect population affected the yield, was there any root damage or not. So once we have the results, I will try to write the results and compile it in our annual report, and it would be published on the ICDC website. And also we will try to highlight these results in our future extension events. Thank you. As promised, we are back with the results for the wireworm study we had on station in last summer. So by this time, we have already compiled the reports and submitted to the Ministry of Agriculture. So as I mentioned earlier, this was an ADOPT-funded project. So the final report, it's submitted to the Ministry of Agriculture. It should be on their resources tools or their website. And also the final report would be available in the ICDC R&D report, which should be posted on the ICDC website in the coming months. So for this study, as I mentioned earlier, we were comparing different seed treatments and how they control wireworm activity in spring wheat. So as I already discussed, like to monitor the wireworm activity, we use the bait traps, and initially we thought that initially we promised in the proposal that we would set up the bait traps 3 times in the season, but we had some extra time on our plate. We ended up doing 4 times in the season. So the bait traps, they were set at seeding. So this plot was seeded, or this experiment was seeded on May 24th, and they were recovered after 10 days. So they were buried in the ground after seeding, and they were recovered after 10 days. So the photo here on the screen on the right-hand side, this shows how the bait traps were set. So each plot had 4 bait traps on each of the four corners. So they were set at seeding, and then we went again and set the traps at heading time, and then at soft dose stage, and the final fourth timing was the maturity. And for each timing, they were left in the ground for 10 days. Coming to the results, so we were lucky enough, as I mentioned earlier, this plot or this field where we had this plot set up, it was a problematic area where we used to see a lot of wireworm damage in the past years. So we were lucky enough that we had enough wireworm population in the bait trap so that we were able to differentiate which treatment was better for the seed treatments. As you can see in the bar graphs on the left-hand side, you would see that throughout the season, the wireworms activity, they were present, and then the activity, it was slow at the seeding time, but as the season warmed up, the heading time, so usually the wireworms, they would go deep in the soil during the winter time or in the fall season, but as the summer or the soil temperature warms up, they would come to the surface and start feeding on the roots of the plants or the crops. And we saw the same thing in our results too. Seeding time, the activity was slow, not much. It was just the control plots where we saw the activity. And then at heading, we were able to find a lot of wireworms in the traps. And again, the peak was at the soft dose stage. And then again, as the temperature dropped towards the end of the season, the activity was again decreasing. Just to give you an idea how much insects or how many wireworms we collected or we saw at each baiting time or trap timing. So again, for the control at early seeding time, there wasn't much activity. It was just like 1 or 2 plots where we actually saw the wireworms. But later on, like the heading time, soft dose time, and the maturity time, we were able to recover the wireworms in all the traps, in all the treatments. Coming to the results, so just to differentiate which treatment did better in case of wireworm control, we found that the control and Cruiser 5FS, they had same number of wireworms in the traps. So they were not significantly different from each other, whereas Lumivia, it was lower than the control and Cruiser, but it was still in the high range. But the lowest number of wireworms were recovered in the Trexa F4 treatments, and that's what this new product was advertised for, that it actually kills wireworms rather than diminishing them or repelling them. So that's what we saw in our study as well. For the yield point of view, again, Trexa F4, it had the highest. Those plots where we applied the Trexa 4C treatment, they ended up with the highest yield. And it was significantly different from the other treatments. Cruiser 5FS, Lumivia CPL, Stress Shield 600, they almost had the same yield, but it was higher than the control. So, and control, where we didn't have any seed treatment, they yielded lowest, whereas Trexa F4 plots had the highest yield. These were the results for this study. Again, I would like to mention that these results will be available on the ICDC website under the R&D report for 2022. And also, if you want more information on how we did or how we set up the traps, just give me a call or send me an email. The ICDC employees would be happy to answer your questions if there is any. Thank you.